Cool. So let's go ahead and get our guests who are helping us out with our database discussion up. We got Benjamin Young and Barry Jones. Benjamin's going to be talking about some NoSQL systems and pulling double duty with MySQL. And then Barry will be addressing MySQL and Postgres as well.
This is MySQL, right?
That's MySQL's in the film.
It's the vacancy.
We'll kick it off with a couple of questions to kind of get things rolling after they do their bios, their intros. And if you guys have any questions,
MariaDB,
You shut up.
some of these guys. If you have questions that you want to ask, just raise your hand. We'll try to acknowledge you if you can. Well, I guess we'll see you. You don't have to stand up. Speak up, tell your name, and shoot the question off. We're ready to go. Cool?
Oh, okay. All right.
I'm Barry Jones. I ran a contract development business here in Greenville for about 4 years. I was recently in charge of a major project for about 1.5 years, about 300,000 active users, intensively hitting a Postgres system, and got to get an intimate look at all of the extreme capabilities that Postgres has. And now I'm a software architect for a company named ACS Technologies in Florence, and I work remote for them full-time.
I'm Benjamin Young, Big Blue Hat online, most places. And I've been in Greenville for 22 years or something, ran my own business for 7.5, and by the same name, Big Blue Hat. And then have done a stint with a handful of NoSQL database companies as a developer advocate, and have recently landed at a nonprofit called Hypothesis, and we're working on bringing annotation, which is commenting and highlighting, to the web. So we're working with the W3C and trying to make highlighting just something your browser does, and leaving notes on public websites and not public websites for the general good of the planet. But yeah, Steven, how do you want to go?
Cool. Barry, can you start out and just kind of give us a history and explain what SQL is?
I won't give you an entire history of it, but SQL is structured query language. It's basically just the standard syntax that's used by just about every major database that you'd heard of before NoSQL databases existed. So MySQL, Postgres, SQL Server, Oracle, Sybase, all sorts of other fringe databases. This was the standard way of interacting with all of that, with all of those systems. It was basically just table-based systems. They all had they all have additional extra functionality built into each one of them. But this core language is a standardized way of accessing and getting that data across all of them.
Benjamin, what's the meaning of the term NoSQL, and what is its origin?
So that's a little debated. Some people just say it's NoSQL. Other people say that NO actually stand for something and that it's not only SQL. Those are the nice people, like myself. NoSQL, I'll challenge what Barry said, existed before SQL, because before SQL, there was no SQL, right? It wasn't around. And so there were databases, right? Sorry. There were databases. So relational databases, I don't know when they came into vogue exactly, but those are usually what support the structured query language. And those came into being after over a decade of tape drives and all kinds of interesting databases that you'll never hear about but are still running at your bank.
Yeah, probably insurance company.
Yeah, right. No, definitely, your insurance company. Maybe your airline, if it's not Southwest. NoSQL in this current dawn started in 2008 in Atlanta. I like to say it was a Southeast invention. The name was, anyway. And it picked up from there. Cloudant was the first NoSQL company to sponsor NoSQL East, which had people who created the company Basho that creates the React database. The MongoDB guys were there, I believe. There were lots of people who are now like household names in the NoSQL world. We're all in Atlanta in 2008 and kickstarted all of that. But that world of databases only has one thing in common, and that's changing anyway, that they don't typically have SQL as a query language. Anymore, though, a lot of them are getting those, and now there's another breed called NewSQL databases that just kind of mess up the whole cozy paradigm too.
Yeah.
So,
Um,
yeah.
And I'll just kind of follow that with the trend that I always tended to see, and you see this in every technology. As a technology tries to fill a gap where it feels there's a need, and a lot of the NoSQL solutions have been filling a gap in where what they saw in the SQL systems. As the NoSQL systems get popular, you see people start to miss some of the features that existed in the SQL systems, and then rather than trying to add them one way or another, they both end up going towards the middle. And there's a lot of NoSQL features that are coming to SQL databases, and now you've got the new SQL, where you're trying to add the same type of functionality back into the NoSQL style of databases. And you see it over and over. Like with we were just talking about this earlier before we walked in with JSON data structures. Everything going on around JSON data structures is reinventing what XML just had finished doing 10 years ago. All the peripheral technologies that existed around it. So just a constant rinse and repeat.
So can you guys both kind of take turns explaining what's the difference between relational and non-relational data?
Well, relational data is basically just when you've taken information and sort of put it into different patterns of normalization, basically just breaking it down so that you're not repeating data structures over and over. And since I've got a group of developers here, I'm not going to go elaborate on this too much, but basically just the idea of having a table where you're defining all of your categories, having another table where you've got a bunch of posts and you're referencing the category ID. Those posts relate to that category. And the more you stretch out and flesh out those various relations through other tables and databases, you can put them back together, and it optimizes for space, helps you avoid replication, helps you ensure integrity and uniqueness across.
So when would you choose a NoSQL database over a traditional relational SQL-based system?
Can we both answer that?
You're looking at both of us.
Yeah, whoever that. Benjamin, go ahead.
I'll let you go ahead first.
When would I choose it?
When would one choose such a system?
Yeah. When would one choose? There are always different scenarios. NoSQL has really taken off. Mostly, I think it got its popularity in part because it was so popular for prototyping. Because they're generally also schemaless, whereas a relational database, you have to define upfront what your schema is for each table. And there's a whole world of other things like entity relationship modeling and on and on and on. And that's also why RDBMSs were very popular with object-oriented programming, because those go hand in hand really nicely. NoSQL, on the other hand, thinks of the world in a very different structure around documents or graphs or XML or all kinds of different things. Key value pairs, your file system, lots of just other concepts besides tables and rows and columns. Although there are NoSQL databases that think in rows and columns as well, so it's a mess. As a family, it's a very diverse family. The times you would use you don't necessarily pick NoSQL over SQL. I mentioned prototyping because I always start with a NoSQL database because I can think about my schema later and I can just go code and get stuff in. But I also don't do a lot of object-oriented programming anymore. My language of choice is, can I have 3 language of choice?
I do.
JavaScript most of the time, Python most of the rest of the time, PHP, yeah, okay, I have 4, and Erlang sometimes, just because it's good to read Greek every now and then. But Erlang actually shifted a lot of my thinking around programming, my learning of Erlang came about because of using CouchDB. So it's flying in the face of SQL and structure up front. The structure in those databases still matters, but you care about it later. So as you're prototyping, you can get into a NoSQL database quickly, but then often you tend to lean on an SQL database. The places I've seen it more often than not are user databases and anywhere where you have schema requirements up front, where you have to know that the data you're getting is valid. If you can care about that later, or only read out the valid data and just say, whatever else you put in here, it's fine. I only want this stuff. Then those scenarios are okay. We should probably talk about different rollout options and deployments, because that's probably when the decision making makes the most sense. If you've just got one box or even two boxes, just pick the one you know. But if you've got a million boxes,
swing back to that one after this next
sure.
one. So, what's a real world example of when you would want to use NoSQL or when you would choose a traditional relational SQL system?
Well, there's a few. For the most part, I do almost nothing but object-oriented programming. My three choice languages, thank you very much, are Ruby, PHP, and Java.
And your fourth, third?
No. I tend to avoid JavaScript like the plague. So that's IE6 did that to me. Don't blame me for that. The relational databases I would tend to use for just about everything, because when I think about a programming project, I'm thinking about it in terms of data. So the very first thing that I do on every single project is design my database. And so I'm designing from the schema out. There are a lot of places where unstructured data will make a lot of sense in that design, because when you start getting to a spot where you're going to have metadata or or data that could have some depth to it, where you've got some data nested within data that's also going to be unstructured, designing that into a relational database can be a bit of a nightmare. You start getting all these fringe tables in that have the names of other tables where the original data actually belongs in it, trying to pare down these different structures, and that can become kind of a nightmare. And you only really need to do that if it's critical data where you're going to be needing to index all those various fields and searching these things. But one of the keys to relational databases is transactions, is the ability to have multiple operations in the database tied together as one. And so, for example, banking operations. If you are moving money from one account to another, you add the money to the next account, you remove the money from the original account, and potentially any other notifications or systems that might need to know about it. But those two basic operations would encapsulate one transaction. And with relational databases, when you've got that transactional system where you can start a transaction, and if either one of those operations fails, everything fails, is one of the main core tenets, because you're verifying, you're guaranteeing data integrity and durability. They always write it to the file system. They always make sure every piece of it gets through. They make sure the data is consistent. If there are any rules in the database that are there to help you define and regulate the structure of that data, the transaction structure makes sure all of those fire correctly, and if they don't, nothing changes. That's basically what ACID is. Atomicity, consistency, isolation, and durability. That's basically all the things that you need to make a transaction happen. As far as when I'd use a NoSQL database, it would vary. I would generally tend to use a SQL database, since that's what I'm primarily using for my project. And then you weren't able to do this before. You'd have to just dump some JSON data or XML data in a text field in your database, and you can't really do anything with it there. But now you've got a lot more NoSQL data structures, the ability to have JSON data types and other relational databases. So if I had a complex structure like that, I could just drop it in Postgres, and then run some indexes on it, run some operations on it right there alongside the rest of my statements. Where I would tend to use it, and I'll actually give you a company that's a really good example of using both together. Has anybody in here heard of server density? Got a couple? Okay. Server density is a company that makes a server monitoring system that you just embed it in your various servers, and every minute it reports everything that's going on in your system. It gives you stats about everything, it gives you a whole log of all the running processes, and there's third-party plugins that'll let you send additional data back with it. They use Mongo to track that data. They initially tried to do it with MySQL, but they were just getting all this data back, and Mongo is built for write-heavy workloads. However, they had MySQL for every other thing at the company. They had one particular data type that was going to be very unstructured based on what was getting reported back, and it had a need to be able to handle very high write capacity, which is something that Mongo excels at out of the box. You can code things up to handle high write capacity, but you have to do a lot more work. It's not built for it. SQL databases are more of a hybrid that's kind of made to handle a lot of different scenarios and solutions. And so what they did was they took the bottlenecking aspect of their application, where they had the high write need, and they offloaded that to Mongo. But they I kept everything outside MySQL. It solved the problem.
Yeah, the transactions use case is a good one. I think in the new breed of NoSQL databases haven't been around that long, and they get used predominantly for those kind of use cases. Most of the drive into that space, besides CouchDB, which predated all of them, was around scalability, and they, especially Mongo, were about outperforming SQL and pushing our RDBMSs. And we're pushing hard towards getting as much data in as quickly, in which case you don't check to see what it is, you just write it to disk and care about that later. Or key value stores like Cassandra or some of these others, where you're just getting it done and then you're dealing with it on the query side. Your data still has a schema as such. You may not have defined it, your user might have defined it, but the point at which it matters is different. On an SQL database, it's when it comes in. So if you're if that's really, really important to you or your application, like banking transactions, and you want to make sure that it is consistent not only within this one instance of this database, but maybe in your entire organization, then you're going to architect that accordingly to make sure that nothing happens until everybody gets it right. Because if somebody doesn't get it right, the nuke goes off early, and somebody changes their mind after it's in the air. So that's bad. But a lot of these other ones do focus heavily on the deployment scenarios and their scalability. So in this accounting case, they model the world as a general ledger to begin with, so a log-based format. And they're only doing debits and credits, but they're doing them in the same ledger versus storing things in different places and moving. They tend to move larger pieces of data around rather than just changing values of components in rows and columns. The normalization stuff Barry was talking about, and they tend to move documents or set whole rows or whatever they traffic in, often JSON or XML. There have been all kinds of scenarios at both Cloudin and Couchbase, both companies I've worked for, that model data very differently. And both companies had a lot of video game development going on. So a lot of this high output apps that are just pumping data into something. And it's often unstructured, and the developer often wants to ship an update that collects one more stat from the player and doesn't want to have to worry about database migrations, which was probably the biggest rock in my shoe when I was using RDBMS, because I did change my schema a lot. But we also had people at Cloudin, like Monsanto, who's dealing with bioinformatics data. And the shape of that changes based on just about every little seed that you could think of, has a different structure and includes different data. So rather than model all that up front, you just put it in however the stats program gives it to you, and you pull it out at the other side. But if there are scenarios where you demand it be correct, like payment processing or whatever, those are the ones where RDBMS is still pretty much reign supreme as far as I know. You can do it without them. There just aren't a lot of people because it's there, and so you may as well use the tried and true one.
Benjamin, back to that point you were bringing up about the deployment.
Yeah. So a lot of the NoSQL databases were born out of social networking companies like LinkedIn and Facebook, Google, Microsoft. All of these people have spun out NoSQL databases of one kind or another. Project Voldemort, Cassandra, there's some others.
I can't believe you said that name.
What, Voldemort? Once he has a name, he can be defeated. Anyway, there's a bunch of them, and the vast majority of them, I keep saying vast majority, I don't know. A lot of them, though, have come from various attempts at solving some part of the CAP theorem. We're trying to get all three, the CA and the P, which you're going to tell me what those are.
That was not on my list.
Yeah, well, no, it wasn't on his either. But the ACID problem and keeping everything consistent, and there are always trade-offs depending on how many servers you have, if you even have a server. CouchDB and PouchDB, which are cut from the same cloth, run in phones and on laptops and are generally very, very close to whatever user interface is writing to them. And then they go talk to another database later and get their scalability at the database-to-database level rather than one interface possibly hitting one of thousands of instances of Cassandra. And it's just going to write to one of them, and then something underneath is going to keep it consistent.
That was always the use case that I heard for. That was always the dominant use case that I heard for Couch. If you were going to have multiple databases that could be disconnected from each other for any given period of time, and you wanted to make sure when they came back online they'd all be able to sync up, Couch was the optimal one for that by a mile.
Yeah, the main reason to use CouchDB, maybe the only reason for some people, is replication, which is what Barry just described. So its approach to the ACID problem is that everybody keeps a by-sequence index, and if we get connected, we're still just writing at the end of this. And when we both come back online, we compare our copies, and CouchDB picks a winner. It doesn't actually give you a way to conflict manage. It does mark it as a conflict if we did write something that is in conflict, which is relatively rare depending on your use case, and then tells the user to go fix it, because no database has ever gotten conflict management right. So anyway, so it keeps the train moving in that way. You can keep going offline. So it takes scalability, this perspective of scalability from a different perspective, that the cloud is a lie. It's never actually around when you need it. Your data, you will never get faster throughput than to your own disk. So you should write there first and then let it go somewhere else later. Most other databases are in the cloud and require server farms and loads of databases to even run them in the first place. And those get scalability from letting you write into memory, and they say, yeah, we got it, and then pray nobody pulls the plug on the database server while we get this on disk, which is how a lot of the benchmarks get skewed.
Yeah, that's exactly what Mongo does.
Yeah, I was going to say that. But yeah,
I'll abuse Mongo.
Sure, thank you. It depends on the use case, though. Sometimes you don't care about your data. I mean, I do.
There's
I
legitimate
like
use cases for that. If you can define some data as dismissible for your performance needs.
His logging.
Yeah, logs. Logs are a perfect example. Where if it's not going to be the end of the world if you lose 5 minutes of just random log data, unless you're talking about bank logs. But if you're just talking about server logs, look at those unless there's a problem. And so unless you happen to have it go out when there is a problem, it's really not going to be that big a deal.
And if there's a problem, you wouldn't have logs.
Exactly.
Yeah.
Exactly. But yeah, I mean, and Mongo ends up working specifically to solve a scalability problem. If you don't mind me talking about that for a minute.
Please.
So you have a whiteboard?
Yeah, sure, go ahead, please.
All right. One of the big use cases for Mongo as a NoSQL solution is that prior to the existence of solid-state disks, and it's still a good idea, but prior to the existence of solid-state disks, the first thing you had to do when optimizing a relational database on the web to handle massive scale was you had to get rid of the joins. And part of the reason to get rid of those joins was because you were doing seeks on disk to put the data together. SSDs have virtually eliminated that. But there's still an issue of in-RAM caching, because the biggest bottleneck to scaling any type of heavy load application, when you're not talking about just writing to your own disk, is disk I/O. And when you've got web servers that are doing a lot of processing on the disk, that's going to kill it before anything else. So the first thing you got to do is get as much off the disk as you possibly can. And so what Mongo does is it writes everything into RAM. And then every so often in an interval, it will persist that stuff to the disk all at once in the background, instead of just constantly doing it as the data's coming in. And the scenario that happens with it is why there was another reason to have to get the joins out of the system. So say you've got, I'm just going to stick with the simple post and category example. Say you've got post. Say cat right now. an ID, a name, and ID, cat, ID, and I'm just going to say content to save the time of writing out every field of a potential post right now. But those two are linked. And so if I was retrieving my post and doing a join right here, this creates a caching problem if I want to store this around. And MySQL keeps a query cache available. But as soon as you write to the database, it has to delete the entire cache. And the reason it has to delete the entire cache is because it either has to say, okay, I'm caching in RAM the result of this one post, or I'm caching in RAM the result of this one ID, and I can either let you operate on that query in memory if we want to. We can cache the result of it in memory. But if we do that, if it changes here or it changes here, then I've got to have some way of identifying when a query is pulling in data from either of these tables and know every single query that could be pulling these tables in and how to delete them from the cache. Cache management becomes insane when you have to do that. Even if you're using a solution like Memcache that's out there, you can define how you're going to cache the data when it comes back. But eventually you're still at the mercy of figuring out what's where. And you can define that at the application level. For a database to extract that, it gets more complicated. For Mongo has RAM and disk, and when you write something, it sits right here in RAM. So the next person that comes in to read something out will get it right there out of RAM on that particular record, because you're pulling stuff in one record at a time. And every now and then it'll get persisted back here to save it in case of failure. But you basically have this entire Memcache solution, and because there's no joins possible with the database, they can optimize this entire caching experience. You're basically just writing your database record directly to the cache at your application level, and it's just sort of persisting in the back. And that's really the biggest reason to get rid of joins, because it makes caching so much simpler. When you get rid of joins and you start getting away from the relational database and you're just pulling stuff based on IDs, you get away from the ability to be able to retrieve records by other fields, by indexes, and you start losing a lot of those abilities. But when you're doing just for pure performance, that's what you end up doing. And there's things, and databases like Postgres have started getting a lot more popular because of the extra features that they've built in to make it possible to manage stuff like this. Postgres now can actually connect to a lot of outside systems, including Memcache. And so now, if you wanted to, you can set your system up. There's a plugin for Postgres to do this, so that whenever you write to Postgres, it immediately, the database, not your application, Postgres immediately, on getting that data written successfully, pushes it up to Memcache for you. And then your application can just do all its reads from it. And so it's just one way that relational databases are trying to find other creative ways of solving these problems.
Speaking of the problems associated with scaling, can you guys address the difference between vertical and horizontal scaling?
Vertical, you make your machine bigger. Horizontal, you add more machines.
Right. You just imagine the boxes going this way, or one box going up.
Yeah.
That's what it looks like. Yeah, come on, Steven. There's some hard.
Something for everybody.
Well, it's a big deal for relational databases because
it is a big deal for
it's
them.
traditionally
It's
been
going-
a lot harder to scale relational databases
Going out
horizontally.
is super hard.
Yeah, web servers you can just keep tacking on your web servers, but scaling out data that's intersected is a lot more complicated.
Right.
And so, everybody in here knows who Basecamp is. Okay, 37 Signals. I actually read one time about how they scaled their system, and what they end up doing to scale all of Basecamp, they have one giant database server running that entire system. One huge vertical database server that has something like, at the time, I want to say it was something ridiculous, like close to like 500 gigs of RAM on one server with just like 80 cores or something like that. It was something ridiculous. But it was easier to scale the database that way. And when you put a relational database on a bare metal machine, you can get a lot of performance that way. Sometimes it's easier to do that than determining certain sharding schemes. That was the other area that Mongo really succeeded, because when you have that simpler cache management process, it becomes a lot easier to shard out your data because you've got one consistent way that you're writing things, So you can define one consistent way to get to it. So you basically do the equivalent of putting a router in front of it that knows if a request comes in for this, it's on that box. And it can build that stuff right in. MySQL actually kind of excels in this area also. MySQL has had master-master replication and clustering for a very long time that has done really, really well as far as being able to just scale out and keep on adding nodes to the cluster. Whereas with Postgres, that's not built in. With Postgres, you have to use one of a few third-party solutions. The third-party solutions are great, but they're just not built in.
Yeah.
With so caching and the actual physical machines for databases being some concerns for scaling, are there any other concerns with traditional SQL or NoSQL database solutions? Any other scaling concerns or road bumps that you kind of need to be on the lookout for, or that you're inevitably going to run into?
I think the one he just hit here, and then I'll bring up another one about deployment options again. The move right around the same time as NoSQL's rise was towards denormalization, which kind of broke the whole RDBMS model. So people were doing that, especially 37 Signals and friends, saying we're gonna get rid of this, and we're gonna start putting, rather than normalize this and actually use the database the way it was intended, we're gonna do a categories field down here, and it's just gonna be like category, comma, category, comma, category. And we'll use some nasty like queries to get kind of close to what we want and then double check and then we'll return it. And so you just had a flat table, which solves a lot of the caching problems. Gives you, because then you've got an ID and maybe some change revision based on date or something like that. So what this starts to look like is a JSON document, right? Or an XML document where you've got typically underscore ID, and then cat ID would be gone, right? And then content, and then categories, and then instead of category, that works. So your category list becomes a JSON array, and then you're done. And so this becomes, again, very easy to cache, because your cache maybe even thinks in JSON, or if it's Mongo, it is a cache. Thinks it's a database, and then in the CouchDB world, you also get an underscore revision attribute that's kept for every change. So whenever you put something or get something, this revision becomes what's called an e-tag header in HTTP, which you maybe have never had to care about. You'll see this if you're ever looking at the network profile section in the console. You'll first request, you get a bunch of 200s, and you see these long bars, and then you hit it again, and it just says 3 or 4 not modified a billion times. CouchDB is the one database I know of that returns 3 or 4 not modifieds if something hasn't changed on every record in the database. But not only on every record, on every query of the index. So if you hit the index, it also has an e-tag. So if nothing's changed in the database at all, everything you requested previously will be coming out of your application's cache. So your browser typically in the CouchDB world, but not always. Sometimes it's your mobile app or whatever. So if you're handling these e-tags and that, which brings me to my deployment thing of the world for a while, right around 2008 again, a busy year, was putting SQLite in everything, right? It was in doorknobs. It was in, like, all of your phones have it. And they were putting it in the web with web SQL. And I think, because you're all doing PHP, most of what you're doing is web stuff. And I think that the web, more than anything, has driven database tech the way it's gone, including the RDBMSs like Postgres and others that are really thinking NoSQL thoughts now. The deployment options aren't just horizontal and vertical anymore, because we're not even talking about server farms anymore. We're talking about that laptop and my phone and that iPad and whatever, and that camera back there. So they potentially could all be running databases, and as we look towards the Internet of Things, which apparently is looming and going to make somebody a lot of money, there has to be database technology that doesn't think about server farms. Like, the era of gigantic single company owned server farms, Google notwithstanding, is kind of over. Or it could be over if we stopped building things the wrong way. So when you can move data this way, when you can replicate it, and when you can store it locally first, and that's what you want, actually. How many of you use note-taking applications on your phone? Okay. How many of you have ever been off Wi-Fi or data and brought it up to reference maybe the address of the hotel you're going to? And it's been like can't get data. And you're like, I gotta find Wi-Fi. Like, where did you put your data? Like, it's behind somebody's paywall, really. You're paying for data, you're paying for Wi-Fi. You can't actually get your data. You have this super powerful machine in your hand on which you store no text. Is there a problem with that? I don't think so. Let's just keep doing it. I said my piece.
Barry's mentioned transactions and touched on ACID for data integrity in SQL systems. Benjamin, what do NoSQL systems have to ensure data integrity?
And I'm going to reference deployment again. It depends on how you deploy it. So in the CouchDB world, which is, the one I'm most familiar with, the database in my phone is ACID compliant, right? It's just me and my database. And if I put it multiple CouchDBs on, then and they're replicating together, then it's a scenario that's called eventually consistent, which came out of the NoSQL world, which consistency is the C in ACID, and this was a cheaty way to get consistency by saying, it's eventually consistent. Like, it's hopefully consistent when you need it to be. So you don't use those consistency constraints, and CouchDB is not the only one who takes that model. Things like, I can't remember the name of it, Paxos. There are network protocols that are built into some databases that were really, really, really hard to make sure that potentially the entire server farm knows that a piece of data has been written and has their appropriate copy of it, or knows where to reference it from again. And that's one option for consistency. But if any one of those routers fail, your database is done until that router gets fixed. So eventually consistent modeling of the world, where appropriate, maybe not a nuclear silo, is much more resilient. And so when the network does go down, because it will go down, it's okay, as long as you can keep writing and keep reading on your copy. And eventually it will be consistent. But you have to be okay with that, with your data. And if it's, did the president say launch the nuke or not, you maybe want higher consistency than eventually consistent. He made the edict on Monday, we got it on Tuesday. Let's go ahead and do it. Or he reversed it. That'd be bad. So accounting and things like that, especially planetary-wide distributed accounting, doesn't tend to go in for eventually consistent. However, the tax guy is fine with eventually consistent. He just needs it by April 15th. So it depends on the kind of accounting you're doing.
Unless you lose your hard drive.
There's that. Yeah. Always make that. Does that make sense? To answer the question? For the most of the other ones, there aren't trade-offs. Usually getting consistency, however you're getting it, will cause problems with the other three.
Soapbox time. Very good for us. Can you explain some of the differences between MySQL and Postgres, and what are the benefits of one over another?
Okay, sure.
Postgres is better.
Let's see. Well, I've used both quite a bit. I've used Postgres fairly intensively for about the last 3 years. I've used MySQL for the last 15 years. MySQL is much lighter in terms of its feature set. MySQL itself is generally just regarded as an interface to a lot of different database engine backends. So you've got NoDB, MyISAM. There's about 9 others that are fairly built into it at this point. There's a lot of other people that provide database backends that can be plugged into it. You can define an engine per table in your system, which is kind of cool. And MySQL got a lot of early bad reputation points because of MyISAM, because it was not a very durable database. Data would get corrupted. It was just going to happen. It was something you just had to plan for and expect. But it was faster in terms of just general performance, and so in the days of just only having spinning disks and machines with a lot less RAM available to them. It was a very good pairing, and it also worked very well with the likes of PHP. You always heard of the LAMP stack, but if you're ever wondering why you always heard of the LAMP stack, one of the big reasons is that whenever a PHP request fires off, it fires up PHP, it loads whatever libraries you need to load, makes its database connection, does what it needs to do in the database, then closes the connection, and then everything kind of terminates. So it's all very encapsulated. And one of the nice things about that encapsulation was that the PHP code wasn't preloaded in RAM, which means that you could fill up an entire hard drive with PHP code and it will still run just fine. You can't do that with other languages like Java or Ruby or anything like that, where you've got to boot it into RAM. But one of the nice things about that is also extremely stable. I mean, there's no garbage collector running in the PHP code, so it can do that. But because PHP was reestablishing connections over and over and over, the overhead of creating a connection to MySQL was next to nothing. It was almost instantaneous. The overhead of creating a database connection to Oracle, which at the time was like the other main competitor you heard of when talking about MySQL, it was like 5 megs of RAM just to connect to the database. I mean, that's why database connection pools were created, so you didn't have to do that. And MySQL kind of found a good way to make that work. But in terms of actual features in the database, there's not a ton built in. You've got your various data types and everything, and you've got to very carefully define, how big your specific text field is and things like that. But if you want to do anything more interesting with the data outside of just storing it in a relational format and knowing that you've got the good clustering there, it doesn't do much. Postgres, on the other hand, had always kind of been known as open source Oracle. It was extremely feature rich and free, and it's gotten over the years. It's gotten tremendously more, and it's gotten tremendously more features. And in the last few years, it's really started to take off. Part of that was people trying to look for an alternative to MySQL after Oracle bought it. But the other part of it was that they made it a lot easier to stay with the latest version of Postgres around the version 9 mark, and they're on the 9-point releases now, but at this point they made it easy to upgrade. Because it's easy to upgrade, it's easy to kind of keep up with lots of features. When we talk about NoSQL databases, you're really just talking about storing and retrieving unstructured data in different ways. And one of the great examples of a amazing feature in Postgres, where a lot of people had been using a standalone system because there wasn't a way to do it in MySQL, is search. I would actually consider most standalone search systems as NoSQL databases. When you've got your Solr, your Elasticsearch, your Sphinx, all of those are basically just ways to do intensive full-text search. The full-text search in MySQL is one of the worst things you will ever see in your entire life. They're basically completely rebuilding it in 5.6, and it should be really interesting to see what happens there. But full-text search in MySQL previously, if you had a table with 20 records, and all of 12 of them had the same word that you were querying for, how many results would you get? 0. You would get 0 results because MySQL had a random arbitrary requirement in there. It says if it will return more than 50% of the rows in the table, you get nothing. So you couldn't use it for anything. One of there's 2 core strengths that Postgres really builds on, and you can feel free to interrupt me at any time. I can go on about Postgres for days. I'm actually teaching a class on it. The core backbone piece of Postgres is that it can hit multiple indexes in a single query, which is awesome. It means that whereas previously with MySQL, if you were going to be running a query that was going to be accessing your category and your date that it was published on, and if it was active or something like that, you would actually create an index that had all 3 of those values in it. With Postgres, you create an index for each one of them. You can query on any one of them individually, and if you're querying on multiple ones of them, it'll figure it out, and it's fast. There's also something in Postgres called custom data types. And custom data types, you're familiar with the ones that are built into to MySQL, like your text and your ints and your varchars and stuff. But with Postgres, there's a lot of other custom data types that exist out there. There's a custom data type for XML. There's a custom data type for JSON. There's a custom data type for binary JSON, JSONB, which is what Mongo uses now. There's hash stores. There are range data types. If anybody has ever built a scheduling system, read about Postgres range data types and then cry because you do not have Postgres available when you built that scheduling system. And one of the things that it has is it has a fully functional full text search capability. It's in it. You can just create a column on your table that will store an entire search index where you can say, I'm going to store the title, the category, my tags, and the body of content. I'm going to make it full text searchable. I'm going to use one of these various dictionaries to handle pluralizations and everything else in it, just like you do with Solr or Elasticsearch. But then instead of having to make sure that it's in sync with an outside system and coding your application to sync all this stuff up, you can just, in like 4 lines of code, you can just create a database trigger that will update it immediately whenever it goes in. And when I say updated, I don't mean that the transaction finishes and your after save hook in your framework fires off and then writes another one to it. I mean, when it sees the record coming in and it sees that it's about to be written to the table, it goes, hey, have these columns changed? Yes, they have. Let's update the index. And then in one database, right, your search index gets updated also. So your search index is always consistent. If you've ever managed a standalone search engine, that gets crazy. And I replaced Solr as a standalone search engine with Postgres Search, and the performance was better. It was more reliable results, and when I wanted to tune it, because it was just sitting in my database, I had access to it. And that's all possible because of custom data types. And the other part of the custom data types piece is that they also have custom indexes. They have 2 types of indexes called gen and gist indexes. And these indexes are basically built to let you define how these custom data types are indexed. So there's indexes that define specifically how that full text search data is in there. There are a plethora of extensions that are in there as well, and people have written outside extensions. If you want to manage geolocation system, look into PostGIS. PostGIS is an entire suite of everything that you need to manage geospatial data in terms of not just in terms of being able to run the queries against the database with geographic data types and measuring distance and comparing intersections and where the blocks correlate. I mean, you can actually rasterize images in the database from this data. You can generate a subway map of New York from your database, and you can run a query to figure out where streets intersect. You can do that stuff because somebody wrote a plugin for it that just fits in Postgres. And there's all sorts of plugins for this stuff. But
so in May, it looked like Postgres entered a beta for supporting like NoSQL outside of just a custom data type for JSON objects.
Really?
Yeah, it looked like it ran into maturity, or not necessarily maturity. I think it launched in some form of beta back in almost the end of July. So we're talking something fairly fresh here.
It's part of Postgres?
Is that 9.4?
That's
Sorry.
the
Is that the
JSON
9.4 with the introduction of JSONB and the querying of those types?
I don't know.
Yeah.
I just know that when we were looking it up, we were looking
Yeah.
for some research and data that was all over the homepage for the Postgres.
Yeah,
Postgres and all this
they
kind of
added the JSONB data type, but it is a data type.
stuff. It's just a simple custom data type.
It is. They have a JSON data type and a JSONB data type, and basically does anybody care what the difference is? Okay, the difference is basically that the JSON data type will take the exact string of text and it will let you write it to the database no matter what. If you have 2 keys that are named the exact same thing, it will let you write that. As long as the structure matches valid JSON, it'll let you write it and you'll retrieve it exactly as it came in. It's a little bit tougher to do operations against it, but you'll get the exact consistent data structure. With JSONB, it is optimized for storage and query. So whenever you do that, it's going to trim extra white space out. Excuse me. It's going to take those overriding duplicate keys, and you're going to just get one of them. The last one that was in there is going to do it because it's going to shrink it down to an optimized, programmatically generated data structure. And so it can do better indexing against it. It can do better queries against it. But yeah, that is the short of it. And it's really fast.
If you use a relational database, use Postgres.
Yeah. Postgres is awesome. We don't have a ton of time, so I'm going to stop talking about Postgres. But I can really go on about this forever. There's
Going
more.
for 9 days in a class.
Yeah, there you go. there's one very specific thing that also kind of the querying multiple indexes at once is big, because you can write a query where you can drop in a piece of a full text search, searching for one column, searching for another, querying against dates and all that. You can do all that in one query, and it will hit all the necessary indexes that it needs to. You can add ranges in there if you need to. You can add geospatial data into it. And you can do all of this in one query fast. But one of the biggest core things that is really useful about it too is functions. Functions in your database. You can in MySQL you can get used to using when you're writing queries to kind of format stuff as it's coming back, to clean up or concatenate some stuff in your select statement. Back when you were writing all your SQL by hand, and that was generally what you would do. With Postgres, you can use functions everywhere, and I mean literally everywhere. When you are defining a table, you can use a function to define the table, the defaults for a field. You can use a function to create an index, and then when you run that function in a where clause, it will query against the function, the index for that function. So I mentioned the XML data type before. Does anybody in here know what an XPath is? Okay. Short version is XPath was like a query language for XML documents. You give it like a URL string, and it knows what to look for in the document. An XML document is just a giant text field, and so you can't index a giant text field, but you can index an XPath function, so that later, if you query that XPath function in a where clause, you can still query against the index version of the data. Additionally, just because I'm talking about XML, Postgres has got something else built into it called Toast, which is the oversized attribute storage technique. And basically what it does is when you have something that's over, if you have data that's stored that's over 8K, it automatically zips it. And to test this out, I dropped in a 2.2 meg XML document, and I checked to see how big it was stored, and it was 81K. And so normally you'd have to store that somewhere offsite and zip it and then just reference where the file was to keep the original. But now you can just drop it in your database and keep it consistent. Good gosh,
I don't think I'm going to cut you off there.
Okay, that's fine.
You could go for a long time.
I really, yeah.
Take his class. I'll plug in.
There you go.
There you go.
Benjamin, your soapbox. If
Yes,
you'd
sir.
like, if you can address the differences and when you would choose one over the.
What are we pitting?
Oh, I didn't get
What
to
do
say
you
when
get
you
to?
choose one over
I think we got which one
Always
you would
chooses.
choose.
Yeah, right. He doesn't ever not choose.
You can't embed Postgres. I'll give him that.
Yeah.
Yeah, no, sure.
Of the NoSQL systems that you've messed with, Mongo, Couch, anything else out there that you've played with, what are the differences? And when would you want to choose one over another, preferably?
It's a big space.
I had my time.
Yeah, right. Yeah. So Barry had it easy because he's dealing with columns and rows in SQL, regardless. Plus extra features in Postgres. So the NoSQL world, as I mentioned earlier, is like vast and broad and deep and confusing and tangled and has no real identity of its own other than what the journalists give it. There are as many popular NoSQL categories as there are popular RDBMSs. So there are the typical ones you'll see are key value stores. There are graph databases, there are document databases, there are hash databases, anyway, on and on and on. So,
Those get used in Colorado a lot.
hash databases, yeah, they do, especially now. All of them basically, all of them come down to two things, really, maybe three. But the two important ones are how you store it and how you query it, how you get your data back out. Scalability and deployment are usually the deciding factors with what you pick, but you might also be concerned with what sort of API you traffic in and what sort of document format you have to put your data in to get it into the database. There are databases out there that will happily take a PHP serialized object and store it for you. Don't use those. Store it in something that's actually like a legitimate format. The vast majority, again, of document storage and key value less about key value, but document storage, which is probably the more popular space, which would include React and by Basha. The keynoter at RestFest, sorry, shameless plug, in a month here, is the guy, one of the co-inventors of React.
Really?
If you care to come here and talk, smart guy. So document storage databases, React, Mongo, CouchDB, Couchbase Cloud, and that whole family of couches. They all use JSON documents, which is what you're probably using in your front-end code anyway, which is part of why they're so popular. There's a whole world of XML databases that do XML in and out, and they use XPath and XQuery and XPointer and X whatever else you might think of to get at that data. The whole family has different ways of storing it on disk, optimizations for either write or read or both. Storage space usually gets punted if you're optimizing for both. But you pick, and it really depends, which is a terrible answer, I know, but it's the answer you get. What's best is to find one that thinks the way you do or the way your app wants to think. I tend to gravitate towards either document databases, of which I pick CouchDB, or Cloud, which is IBM owns them now, and it's a big hosted, gigantic couch in the sky. Or with full text search. And geo-indexing, too, actually. So document storage and something like Redis, which is a key value store that also understands some hash algorithm stuff like sets and things like that. So you can do some amazing statistics things. And usually a very nice cocktail are Redis and CouchDB, because CouchDB will get you your consistency and your persistence, and it's getting it right on disk. You're not losing anything. You can replicate it. You can scale out. You can put it on your phone, etc. And Redis, if you want just crazy throughput on your stats or on your documents, because it's going to 304 to your browser anyway, you can put Redis and Nginx in front of that and cache it in Redis, and then start loading your CouchDB docs that haven't changed out of Redis. And so your distance is even shortened there. But then if you're just counting numbers that you can recount anyway, that's data you can afford to lose. So you put it in Redis, which is a key value store cache thing with a lot of smarts. Neither of those do what?
It's very good at sorting.
Yes, it is extremely good at sorting. So if you have like a leaderboard or something like that, it's great for those. CouchDB can do it as well, but there's no reason anymore why you have to pick just one. It's really nice. The candy store you always wanted. Probably when to pick what is to research based on what you're building, what there is the most tooling around for what you're building, or prior art in a space. The gaming world tends to gravitate more towards NoSQL. Watch that space if you're building a game. If you're building a CRM, what you should do is try lots of them. Find one that feels right for you, that you can get cozy with, that has what you need for whatever PHP framework you're using, or one that doesn't need a framework or library like CouchDB. It's just doing HTTP and JSON, which PHP has known for a very long time. And try to learn what the database can offer you. Too often in 15 years of PHP programming, I didn't learn for a long time what even MySQL could do, and was just happy to do some ORM wrapper and hope for the best, which means things would get strangely slow because of crazy joins that the ORM would have built into the migrations. So we stopped doing that. And thinking in the way your application thinks about your data first, and then go, not necessarily schema, but maybe schema, and then go find a database. And what I mean by that is, in my case, I was building a content management system like too many other people, and those deal in documents. But despite that fact, Brad Garrett and I, sitting in the back row, spent the better parts of our childhood building yet another RDBMS-backed CMS, which meant we were taking all the documents and forms that people were posting to the CMS and tearing them apart into columns and rows and putting them all over this database. And then when somebody asked for it, what do we do with it? We went and collected them all back up, taped them back together, and sent them back to the person. And it was like most of the architecting and time we're spending is in this layer that doesn't actually do anything but take the stuff apart and put it back together. When really what I want to do is take whatever the user gave me, store that, and when they want it back, give it back to them. Which means I cut out the vast majority of the programming I was doing. I wasn't writing SQL queries anymore. I was deciding what my JSON looked like and how I wanted it to look in the browser, and then building indexes for how I might want to get at it later. So that shift to a document storage database for what I was building, which was already document-centric, was great. If you're building something that thinks in tables and rows, use an RDBMS because you're thinking that way already. But you have lots of options, and you don't have to pick just one. Is that a cheaty answer?
That's a great answer. Informative.
Actually, just because you're right, everybody has built a CRM or a CMS.
Well, that too.
I did the exact same problem,
Yep.
solved it a different way. What we ended up doing was we found that most of the time that we were spending on our application development with Brightball was the front ends of the sites were actually really simple because it was just basically, for the most part, we were just displaying information. And that part was the easy part. I mean, we were taking a design, getting it sliced up into HTML. The complicated part was giving a back-end interface for people to manage all these different document types. And so what we ended up doing, we were very big into Cake PHP. And at the application level, we built around Cake's ability to inspect a database and understand the data types that were there and know what types of data were described in your tables based on the structure that you gave them, whether it was varchar, int, or date, or whatever like that. And what we ended up doing was we built an entire system that, by understanding that data structure and the rules, we'd go in, we'd talk to the client, we would learn to describe their data. We'd go and design the database, and the entire administrator system just, poof, just appeared. And we built in a permissioning system on top of it so that we could give different user types different access to various levels of the data. We could just turn it off on a field level. So all we had to do for any of our jobs from that point on was to design the database and slap the front end HTML on, and we were done, which was awful for billable hours, so it went out of business. And that's serious.
Type slow.
And we started out with quotes for projects like that were $70,000. By the time we were done, the quotes were down to 50, or not 50, or down to 5. I mean, we cut out 80% of the project work by automating that. So it was a fun problem to solve, but not good for business.
I would say that a couple years ago, one of the big guys in Drupal had mentioned that he was seriously pushing them towards having Mongo as a backend. I think Drupal 7 already has that plugin, but I think that's coming to CMSs like Drupal, where it doesn't matter what you want to write to for that part. I think with Drupal, the idea was, if anybody's ever seen Drupal 7 content type fields, every field you create on a content type is a table. So you end up with one content type and have 50 tables to it. So it makes a lot of sense. But I think they were, I don't know if sharding is the right word for this, but they were talking about, let's just take the document specific content stuff and put it in Mongo, and now all the other stuff doesn't necessarily need to go in Mongo. And that sounded like the approach they're going to take. We're going to put some stuff, mainly our content types or CCKs in Drupal, over to Mongo. We'll leave other stuff we think we need over here in MySQL or Postgres or whatever else you want to plug into.
Yeah, and it's actually funny. A long time ago, that the system that we built was only possible because of all the work that the Cake PHP guys had done to build a system that whenever it fired up, it went and inspected and described all that stuff and tied it to an ORM that we could look inside with our code and find out what we needed to do with that data structure. But at one point, the Cake projects kind of split off when they were still in their 1.1 versions. They were going to have a Cake 2 and they were going to build a Cake 3 at the exact same time. This was years ago. Cake 3 just came out, and it was a completely different project from the one that was spec'd at the time. But those guys ended up going and deciding to create the Lithium project. And they got it to version 0.9, and then for about a year it sat there, and then it went to 0.99. And it slowly just kept adding on 9s without ever hitting version 1. But they...
union of rad.
Yeah, Union or Brad, those guys, and it was it was really interesting the way that they thought about the problems, but they were trying to solve everything that they ran into in Cake. And one of the main things they did as part of that was their primary database that they recommended people use with the framework Lithium was Mongo. And they were primarily going NoSQL first to avoid having to redo all that work that they did to build an ORM layer on top of it. And that was around the time the PHP namespaces had just come out, and so prior to those namespaces, there wasn't just a library that you could just plug into all of your frameworks that was already just a good ORM. You had to keep reinventing the wheel every single time you built a framework.
Cool. Thanks, guys. I want to see if we can open up. If anybody has any questions, feel free.
The answer is Postgres for any questions.
Unless it's CouchDB. Right?
Oh yeah. Unless you need it, no.
Unless you want it on your phone.
Yeah, exactly. I'll go with Postgres as the 95% of use cases as far as my stuff, just because my stuff's all web stuff and not games. And all the various peripheral tools that it provides you give you all that extra application stack. But that's just
Sure.
Any questions?
So, I'm a Postgres guy, but I'm
Good choice. Correct.
but I've been, for gosh, ever since probably 2008, looking for instances to use NoSQL databases. And like our app, it's built on Postgres, but we also use Redis
Sure.
for a handful of things as well.
you're coding in Rails, aren't you?
I am. I'm a
Know
Rails
it.
guy. So, yes. And yeah.
Hey, this is a PHP group.
Yeah, I've been doing that forever. So 0 to 13, I think, is when I started in Rails. So 2005. Anyway, so my question is really about, so your data is, at the end of the day, I mean, even if your framework dies off, you have this data, okay? And so people want, generally, analytics. They want all this stuff out of data. So every time I go to the document store, I have this stuff, and we have kind of like the whole MapReduce thing to kind of do certain things. But I guess, growing up in a relational model, it's like, okay, you have all this data. Yes, it's normalized, and the point for like on the web, the front end, you're deconstructing and constructing it. And that's great. I mean, it's not great. It's a pain in the butt. But the fact is it's deconstructed, so then you can actually go build analytics and tools to actually, do all this aggregate functionality and things, dashboards and whatnot. And so, and again, my world is small. My world is, not distributed thousands of data centers. It's like a small company growing, and so I don't have like those kind of problems. So I don't want to have, a handful of different databases to manage and like go here for this or here for that. So I was just curious from a standpoint on the NoSQL side, what do you do when you need this? So you have document stores that have schemas have changed over time, different data stored in there and everything else. And someone says, okay, I want to get analytics out of it. What's the approach when there's not a schema to necessarily do that with?
Sure.
Some data may be there, may not be there. I'm just curious how you would approach something like that.
Right. So we mentioned earlier that most document storage databases, CouchDB being the one I know best, don't require schemas up front. So they're not requiring a schema at write time. So the schema doesn't matter when it comes in necessarily. You can make it matter. There's a way in CouchDB and Mongo and all of them to require certain fields in the JSON to be there and whatever, which slows down your write. So you just decide about that trade when you do that. But regardless of that, it doesn't have one by default. Where the schema matters is on the flip side when you're reading it, either when you read the document directly or when you're building a MapReduce index, which is a form of reading, because you're going through all the books in the library and deciding what Dewey Decimal they need to have, and then building your Dewey Decimal deck over here. And then you're going to go through that to come back and get the document that you need. So, and those can be infinite, whatever number of indexes you want, whatever type of index you want, geo, full text, whatever, even SQL. There's people who have played with using MapReduce to go through a stack of documents and turn it into a table, and then using SQL to query the table you made. Doable, kind of weird, but doable. The question you asked about what if all my data is not there, and it's the same scenario that you deal with in life all the time. I've described it other places as MapReduce is what you do every day. You don't do SQL. You take, when you come home from a conference, you pull all the receipts out of your pocket and business cards and everything else that are in there, and you say, what can I expense? And you say, okay, that's a business card, that's a receipt, that's a business card, that's a receipt, that's a tchotchke, that's a receipt. And then you go through the receipts, now that you've mapped them out to just receipts, and you reduce it down to a number. You give that to your boss, and hopefully he pays you back. Right? So that's MapReduce, and you do it all the time. You do it, once a year when you organize your desk or whenever that is. So when you go into that scenario, you might find a receipt that is faded, right, or is rubbed out or crumpled or beyond recognition or whatever. Hopefully, you can get the data somewhere else, or maybe you ignore it, because, as in the case of logs, not everything is a log, but there are times when you can ignore that data. Your scenario is not probably one of those times, since you're dealing with payment tracking.
Hopefully not.
But it really depends on where you're getting your data, how much you trust it. And for one of the frustrations I had with the RDBMS world and building a CMS on it especially, was that I was already doing data validation in the client. Right? I'd already built up all these JavaScript rules. I already made sure my form was nice. I was even telling the user before I even let it hit the server, let alone all the PHP code that did it a second time. And then I had the database doing it a third time, and I'm like, why? Why? Just like, I'll pick one and let that be the thing. So it could be your server code can validate it before it hits the database. If you have an API, that's where you would do it. Or it could be the client. And now, yeah, somebody could screw around with the client, but depending on what you do in your query, that data may not show up. So if it's invalid data that got in, you don't want to see it anyway. If it's data with stuff missing, you need to figure out why it's missing, and you can write indexes to show that data is missing, right? You can say, this is what I want my documents to look like. Tell me if there are any documents in my database that don't look like this. And then let's find out where they came from and make sure that doesn't happen again. Because it's likely a bug or an error or a user screwing around with your UI or whatever. But you don't need 3 points of validation, certainly. And a lot of times you can validate it on the way out and say, yeah, okay, that's just invalid data, and we're not going to deal with it.
And also, just to give you an assist on this one a little bit.
Yeah.
Does anybody in here know what ETL is? Okay. ETL is basically a language standard for moving data from one place to another. It's used in data warehousing all the time when you're moving data from huge data warehouses and tape drives and long old systems into systems that are built specifically for analytics. And so when you have tons of data, whether it's in NoSQL format, whether it's in file structure format, whether it's in whatever else, this language exists for the sole purpose of taking it from these other formats and moving it into usually some type of column or data store, like an analytic database, like an InfoBright, which works with MySQL and Postgres, for example. The free version does. The paid version is $20,000 per terabyte per year. But if you're familiar with, if you've heard of Amazon Redshift, that is the same idea. It's a column-oriented database. What a column-oriented database basically does is you determine how to structure the data that you have in some type of tabular format, and then what it basically does is it loads up and auto-normalizes every single piece of data that goes in. You'll get compression ratios of like 112 to 1 as it's shrinking this stuff down, and they're built to shrink all this data, make every single column into some type of index, auto-normalize all of it, and then dedicate the entire power of one machine to running one query as fast as humanly possible. And previously, giant businesses would use something like Oracle so they could, so they'd have the privilege of being able to write one of these queries and have it finished running in like 3 or 4 days. These systems will do it in 15 seconds. And that's exactly what the likes of Redshift is for out there. If you've got stuff in the AWS cloud, you can, I believe Amazon's got something called, I'm fairly sure their equivalent to ETL is called something like data pipes. But it's basically set up to let you move stuff. Like you just script it to move it into Redshift. You load it all up. You run your query real quick, and then you just tear it down. And you have the ability to do that whether it's NoSQL data or structured data. You just have to define how to go from that format to an analytic format. And that's if you're using Elasticsearch or anything.
And remember, you don't have to pick just one. And you rarely do pick just one anymore.
Like Postgres, as I go on, is for my 95% use case because it's got all these other tools that support application needs in them without me having to go get those extra systems because I don't like doing that either. But what it does is it basically just reduces my need for those outside systems to the edge cases where I really absolutely need, where they do the thing that Postgres doesn't do. Like, I mean, if search is the critical piece of my entire application, I'm better off using a standalone search system probably. But if it's just a feature that's getting used by some of my users all the time, I don't have to dedicate hardware to it. So that's
We're running out of time. We got a few minutes. Any more questions? Cool. Thank you guys very much for being here.